So, good evening, everybody. Today we are going to speak about this EMR Part 3. The usual disclaimer, I really love what I do, but it doesn't mean I'm the best. You're welcome to challenge me, to talk to me, to ask questions, anything to make the discussion more and more interesting. So those of us who are new, we have a community called Big Data Demystified. You can join us and see the lectures later in the website. A little bit about me, lots of experience in the high-tech industry, from startups, from media companies such as Walla News and Investing.com, some enterprises like Intel, Deloitte, and MSD, and then naturally IBM. And I founded my own consulting company in data, and 4 years ago I started lecturing about data just for fun. And the community grew worldwide, over 10,000 followers worldwide. I have a tendency to jump out of planes as a hobby, and I'm a martial art instructor or third degree black belt in Taekwondo. So in the past, everything was simple. We had a 3-tier architecture, operational DB, and API, and web server, and then everything was copied to the data warehouse. Then came big data, making everything much more complicated. And then came the cloud, making it more and more complex. And then came the invoice, forcing us to take into account the costs when we work and design architecture. So it keeps growing and becomes very complicated. And my methodologies, taking the best of two worlds, cloud methodologies and big data methodologies, and this is my philosophy regarding data engineering. So today's session, we are going to talk about a couple of subjects which are important to understand what you're doing, and then we're going to try to test that knowledge we acquired in the last 3 sessions, including this one, into an exercise. Hopefully it will make everything clearer. So let's talk about the relevant jargon. It's about, first thing would be about encryption. Okay, I'm going to mute those who are not speaking. Feel free to unmute yourself whenever you like. First thing joining, which is great. So, today's session, those who just joined, we're talking about a few more concepts, and then we're going to do some exercise from the homework. So, encryption. Usually when speaking about encryption, you don't have to be an encryption expert, but you do need to understand the basics. And what are the basics? There are at least 2 types of encryption you should take into account when designing an architecture. I will be looking to my right as my monitor holds the slides over there, and I'm going to look over here to observe you guys when you open your mics or your videos. When you talk about encryption, there are 2 terms you should know: encryption in motion and in rest. A simple typo, allow me to fix that. At rest. When you talk about encryption in motion, it talks about encrypting the data moving out of EMR and to S3 back and forth. So imagine a simple client-server architecture where the client and the server are talking to each other back and forth, so all the traffic is encrypted. The concern here that someone with the red arrow would be malicious enough to hijack the traffic and to perform a cyber attack called man in the middle, essentially grabbing the traffic from here and sending something else to the destination. There are naturally other risks as well. You don't want people to read the traffic once left either sides. Encryption at rest usually implies once the data moves from the client to the server and lands on the disks, it needs to be encrypted. It's for a scenario where, for example, a server is turned off and there's data on the disks, and someone comes and takes the disks. Will he be able to open the encryption? Will he be not? Will he be able to read the files? So essentially, you want to avoid the scenario where someone grabs the disk and opens it in his own computer and making it difficult for him to decrypt the data. Is this concept clear before I proceed? Great. So encryption at rest is a bit more complicated when you talk about the three possible ways to encrypt at rest. 1 second, please. People are still joining, which is great. Okay. That you can divide encryption into two categories: server side and client side. Encryption, which is server side, is usually managed by Amazon for you, and it's divided into two subcategories. One would be S3 manage, which is essentially telling S3 we trust AWS and S3 managed service to create a key for our account and manage the encryption and decryption for us. A KMS key is essentially a managed service that allows the customer to create keys but let AWS manage them for this use case. It's usually the next step forward if you want to do the most basic encryption. You can use S3 manage. If you want to use server-side managed, you can encrypt that using KMS key managed, and this will let you do things like creating two sets of data in your own account with different keys. The client-side encryption is used for scenarios where you don't trust AWS, or you trust AWS, but you are concerned that the government will issue a federal warrant to request for the encryption keys and the data of your company. So essentially, in that scenario, if it's server-side encrypted, one would be able to decrypt the data. But if you use client-side encryption, essentially, you put your own key, and AWS has no idea what's that key. You give them the key to encrypt and decrypt every time you need the data, but they won't be able to pass it along to a third party if a federal court of law requests the data for some reason. Is this concept clear before we proceed? Just to be clear, 99% of the use cases, unless told otherwise, you're going to use server-side encryption and S3 manage. EMR cluster configuration. There are lots of configuration that comes with EMR, but you should know that for each scenario, you want to configure it a little bit differently. There are three scenarios I've prepared for today's session. One is a transient cluster when it goes up, does the job, and then dies. And then a 24/7 cluster for automation, and a 9 to 5 cluster, which essentially goes up at 9 a.m. and dies at 7 and lets researchers do their work. Transit cluster is usually fixed in resources as the cluster runs nightly, so predictable resources are to be expected. The challenges are usually around predicting volume and velocity of your use case. Is this use case clear before we proceed?
So what do we mean velocity and the volume could be a change? Can you give an example?
Yes. The thing to consider about big data use cases that the amount of data keeps growing over time. The more it grows, the more it will become challenging for your infrastructure to operate. So if you're going too fast, then you will break every day. But if you're going slowly, you'll break once every blue moon, say once a year. So this is usually affected by the volume of data you have and the volume of data you're trying to process. Okay. Is this clear?
Yeah, yes, okay, thanks.
Thank you. So a 24/7 cluster usually there's mixed workloads and many type of automation run on top of it. The challenge is that it usually has Power Query jobs, jobs that consume most of the cluster resources. And it also contains small and fast jobs, low priority jobs, high priority jobs, and there's lots of monitoring challenges around it because you really don't know when something goes down, when something breaks, how to tackle it, how to make everything work, and so on and so forth. Is this use case clear? Feel free to use the chat, guys. I'm tracking that as well if you like, for your convenience. Yes, thank you. Okay. A 9 to 7 cluster is usually where you have an office hours, say 9 to 5, and then it has some automation, some researchers working on it, and you want to combine the workload a little bit. Whoops. Okay. And the challenges around it are usually around concurrency, how many jobs can work in parallel, predicting the amount of resources you need, and what happens if you don't need the cluster. I mean, you let it run 24/7 and essentially utilize lots of cloud resources which are unused, and because you're paying for that. Is this use case clear? Okay. So let's talk a little bit about job configuration. before we dive into that, we really need to understand the mechanics or the delegation of authority within the cluster. This is a slide from previous lectures. And when you have a job, essentially you're asking from the Yarn service, which is a resource management service, for compute resources, which are essentially core nodes and task nodes. And yes, you have the storage as well, either it's HDFS or S3. Once you do that, once a job is requesting resources, it's either getting those resources or not. What does it mean? For example, in this slide, we take job 1, which requires 4 CPUs and 16 gigabytes of RAM. Gigabytes, let's make it gigabytes. So essentially, job 1 is requesting 4 CPUs and 16 gigabytes RAM, and you have a cluster of core nodes with 14 and 4 CPUs and 16 gigabyte RAM. Same goes for task node. So essentially, that job can run on these machines. Whether it's in parallel or not, it doesn't really matter. The compute sections will be divided equally between these two, because each of these servers have enough resources to run this job. However, while this job is running, the second job will request for resources and the yarn will deny, because it would say the cluster is fully utilized, please wait. Hold the line while we'll provide more resources going forward. Is this clear? Okay. So in order to optimize your job configuration, there's lots of configuration you should do, and I took the liberty of putting some major ones you should be familiarized. You should get yourself familiarized with. The first one would be the Spark Executor Memory, Spark Executor Core, and both of them are quite simple and quite trivial. You're essentially telling Spark, listen, for this job to run successfully, you need 16 gigabytes and 4 CPU cores. I'm gonna talk about the dynamic allocation enabled soon. Maximize resource allocation is essentially saying, if I'm asking for 16 gigabytes and 4 CPUs, but you have more resources, then please assign the maximum you can assign, which is quite nice if you don't know your cluster setup. When you talk about dynamic allocation, you're essentially telling Yarn, listen, I'm requesting this amount of resources, but if you have more, please double them. So every time there's a doubling process, essentially Yarn is trying to allocate more and more resources for the job until it reaches a certain amount of maximum resources spent on the machine. This is especially useful when you have a 24/7 cluster and you don't know what's going to run when and why. And another one important is the Spark driver memory. Usually when you are requesting something from Spark and Spark is returning to the client side X amount of gigabytes of data, and you ran out of memory on the client side because the driver wasn't allocated enough memory. There are lots of good reads I've prepared here on our website. Should you find it more interesting, you can read that in more detail. I try to make it as simple as possible. Oops. Trying to open the second one. Yeah. Trying to make it as simple as I can with some example. But for now, let's stick to the definitions we have in place. Another section you should definitely be familiarized with when you work with EMR is monitoring. Essentially, Ganglia is an application for monitoring. You can install it while deploying EMR by simply checking the Ganglia checkbox to install once you select all the different applications that you want to be deployed on your EMR. This is a real-life example of an EMR cluster running in a specific job, only job. And once you see here is blue being utilizing resources utilizing the cluster, and orange is that Yon is requesting for resources, but not getting it. So essentially, this cluster is not configured correctly because it's requesting resources which simply don't exist. What you can see here is the memory allocation, that the entire cluster has about 600 gigs of RAM total. It's more or less consuming half, which is to be expected. Given enough configuration, patience, monitoring, you should be able to utilize the cluster and configure it in such a way that you'll utilize it perfectly. See the utilization around 80%, and the memory around 1.5 terabytes. This usually implies that you did a really good job because you're utilizing about 70–80% of your cluster. Any questions about this? Okay. Homework. So we took the exercise from previous homeworks to design a transient cluster, which you know by now what it is. Running nightly, running 4 long-lasting compute-intensive jobs with flexible time window, meaning it's up to you if it's sequential or in parallel. So now is the time to open your mics and let's discuss how would you approach this. I created for your convenience some sort of a framework, something that to help you, like a questionnaire on how to tackle this, and we'll fill it together and make a discussion if you like around it. So the first question would be, how many corners will you put in this cluster architecture? Please open your mics and let's talk. Amos is requesting the links, so I'm going to put it over here. Putting it in the chat. Okay. Going back to the lecture. Would you like to give it a shot? Open your mics and let's talk. Anyone? Okay.
Well,
so please.
let's say that we started with 4 nodes and we're going to auto scale just as a starting point.
Great. And we're going to auto scale. Are you going to use task nodes?
I haven't been to all the lectures, so I'm not sure what a task node is. I can look it up.
Okay, so essentially a task node is like a core node without the HDFS section, which is the Hadoop file system.
Oh, okay.
Okay.
Oh, okay. So you could add like task nodes. Can you get it to scale the task nodes instead of Hadoop nodes?
Yes, and essentially that would be a good idea. Between 0 to how many would you figure?
Well, let's say 12.
Well, let's say 12. Good. Are you going to use HDFS, S3, or both?
Well, mostly, from my experience, we would use S3 a lot. HDFS is kind of a limited space. I don't know how much. It depends maybe on the configuration. We were using AWS and we had a sort of limited amount of HDFS space, but lots of S3.
Great.
But
you shouldn't even pay attention to the fact that it's a transient cluster, so you really don't want to spend time on your HDFS because it's going to die essentially when the job is finished, the cluster. So S3 would be your correct type. What would be your instance type for the core nodes?
Well, that's an interesting question. Does this include GPUs at this point? Because I noticed that you can configure GPUs on the system now.
Yes, I noticed that as well. But for now, let's assume for simplicity, no GPU nodes are required.
Okay.
So what would you recommend? Please.
A C4 node.
Sorry?
Is a C4 node?
C4?
Yes, C4. We can use X large.
X large?
Or just large, yeah.
Okay. And what about the task nodes?
So looking at the fact that we've not introduced HDFS, it means it may not be task intensive in terms of the memory utilization. So we may go with something less than C4. I think maybe T4 large or something.
Never use T instances for EMR because you're going to use them once you use them and you don't want it to slow down your job. So any other instance type would be the more logical choice.
D2.
D2?
Yes.
Why D2?
I'm just trying to scale down from T2 the T options. So it is D that has come to me like really fast.
So why not use the same instance type? Like in the corner.
Interesting. I thought it was not going to be tax intensive or memory intensive.
Even that's why you have auto scaling on the task nodes.
Okay. So
okay, so let's use the same. Yes, yeah, it's a safe bet to to use the same instance type. Okay, what would you use for the master node? Any guess would be a good start. Why not use the same machine? Start with something. Use monitoring and then adapt. That's why you put monitoring.
Okay.
Right?
Okay.
What about encryption? Are we going to encrypt?
Yes, I think the KMS will be okay.
KMS. Encryption is a best practice. Okay, what would be the billing type for the instances? There's on demand, and there's spots, and there's reserved. Which one would you use?
I think on demand, because it's transient kind of architecture, so that whenever it's
Yes, good choice. Good choice. So you want to use on demand, so AWS will for sure allocate your machines for you. Naturally, you can optimize that with spots later, but for now, it's a good start. Okay, let's talk about the EMR configuration. What would be the CPU configuration and RAM you would put as a default for your job?
Oh, okay. I'm going to try. Can we go with 4 vCPU for the RAM?
4 CPUs and how many gigs?
96 GB, I think is okay. 48 or 96.
48 gigs? This is what you meant, Amos?
Yes, that is what I picked.
Okay, so but let's be sure we talked about C4 instances, and we want to check the spec of C4. So let's talk about compute optimized jobs, C4. Extra large, we have only 7.5 gigs and 4 vCPUs. So we cannot go over this. Okay?
Yeah.
Okay. We're getting places. This is good work, guys. Should we use dynamic allocation? Remember what dynamic allocation is? This slide?
I think so.
When should you use the Spark dynamic allocation? You remember we mentioned it in this lecture.
Okay, so what I don't understand is if we use dynamic allocation in that particular kind of scenario, and the C4X large only has 7.5 GB of RAM. I don't know how that will be in a position to allocate the Spark memory executors and the cores when it's clogged. So I don't know if it's okay to use it because we've already exhausted the number of RAMs in the CX4. Maybe you can advise.
Yes. Good observation. So one, we already assigned the maximum amount of resources per machine. So there is really no point to assign it. No point at this point to assign dynamic allocation. But let's assume for a second you choose a bigger machine. Is dynamic allocation right for this use case? Because the use case is saying, listen, you have every night 4 jobs, long lasting.
Grillers. I'm just
Oh,
saying
grillers. Oh, yeah.
Richard, I'm gonna mute you if that's okay with you. Okay, Amos, you with me?
Yes, I am, Omid.
Okay, so we said dynamic allocation. It's not no point because we already used the maximum amount of resources. But let's assume we have a bigger instance, say
Can you
16.
can you just open up the EC2 instance type that you already opened
Yes.
up there?
Let's say we choose this one, 8 extra large.
Okay, so
C4,
if you
8
choose
extra
8,
large. Yes, please continue.
so maybe if we choose 8x large and maybe we give an initial configuration of let's say 4 can we get 4 vCPU from that 8x large?
Yes, why not?
I think so. If that is the case, we can use the dynamic allocation because we can start with the lower memory. Then the more the task become intensive, it can now be using the allocation that of the remaining vCPU and RAM as well to scale.
But the use case implies every day, 4 jobs, long-lasting, compute-intensive. That means you need the maximum amount of compute. So why not use this setup instead?
Okay.
Does this make sense?
Yeah, and now it makes sense. Thanks.
Yeah, let's put it this way. AQ, forget that for now. That's for today's session. What about replication factor on the storage? Should we change something, use the default? Should we consider that at all? Any idea? Who here wants to explain replication factor? So let me try and bring up the slides from last time about EMR2. Sharing my screen all over again. Please confirm you can see my screen. Can you see my screen? Anyone?
Yes.
Yes.
Thank you. So let's go over the slides. Find the slide about replication factor. Dum, dum, dum. Replication factor. Do we remember this slide? Imagine you have a cluster with 3 nodes, and each file with a replication factor of 2 is replicated at least twice. This means if in node A you write a file, for example the green one, it should be replicated at least once to another server. Right? You with me so far? Okay, so answer me this. Now that we understand what is replication factor 2, should we change something? What's the benefit of replication factor? Anyone?
Hi, Omid.
Hi.
Yeah. So I think 2 is enough, right? Because it is a transient cluster. So if one node fails, we still have a backup. And because it's transient, we don't expect multiple failures within a short period of time. So I believe 2 should be good.
You're right, you are, but I want to put your attention into one thing. Replication factor usually entails Hadoop file system. Did we choose HDFS or S3 in our setup? What did we choose? We chose S3. Right. So what's the replication factor for S3? S3. That's why you call it S3. You have 3 replications for each file you write. So can you configure it? No. Should you configure it? No. So essentially, it was a trick question only, or not a trick question. It's a framework designed to help you think only in HDFS scenarios if this is relevant. Okay? So in our scenario, we chose the scenario. We chose not to use HDFS, so we're good. Okay. Job configuration. So essentially, previously we decided to configure on the cluster the default of 4 CPUs and 7.5 gigabytes, but we can set each job manually should we choose. Since there are 4 jobs, we may want to override the details, the default values. And what we should know about the job is the IO pattern. Is it read intensive, write intensive? Is it compute intensive? So it will make sense to know what to do, how much round trip time there is on the network, and so on and so forth. But this is unfortunately something you can do only after you run the job for at least once. Thank you, John, for your comment. So essentially, what you're saying, what you see here is another thing to consider while configuring your job. You don't have a lot of information about the job at this point, but you do know that since there are 4 jobs, you may want to override some values. Let's talk about the storage layers. Anything to consider around that? What was the technology we selected? S3, right? And the tables. Are we using Glue for that? Or are we saving them locally? Should we talk about this? So essentially, we're going to use Glue because we want to save all the data outside all the table metadata outside of the cluster, because the cluster is transient, so essentially it will die once we finish. What about the partitions? Is there something we can do around the partitions? So since we know nothing about the job, we're not going to touch the partitions, but should there be any performance issues, this is the first thing we want to examine. And the storage format, same goes for that. We're going to use whatever is out there on the S3 layer because the data already exists, it's already running nightly. Same goes for compression, file size, encryption, we said we always do. What about IAM? How would you address the permissions? What would be the methodology you want to imply over here?
I think giving access to Glue and also S3 to be in a position to write on S3.
Mm-hmm. That's basically it.
Yeah.
You nailed it. Good job. Okay, any question about this use case before we switch to the next one?
I have a question on partitions.
Yes, please.
So in case maybe we are using HDFS, or maybe we run into performance issues, where are we supposed to be doing the partitions? Is it on the Spark jobs, or we're supposed to be doing it on HDFS? Yeah, so maybe
On
you
the
can
Spark jobs,
clarify
you
that.
will be able to play with the partitions, make it smaller or bigger, depending on what were on the job, because it's a logical thing. There's also a physical thing on the storage layer, but you might want to consider the output of each job in a different partition. You can test and play with that as well.
Okay, thanks.
Okay. So the next cluster or exercise, we are going to design a 24/7 cluster running mostly from 9 to 5. Mostly from 9 to 5, that means it's going to run 24/7, but most of the work will be from 9 to 5. And a group of 10 analysts are going to use it. Very nice. Is the use case clear, guys? Great. So let's talk about the architecture. What would you put in the core node count? Anyone? So what is different from this use case from the previous one? We decided we're going to use 4. Richard, what made you choose 4 for this use case? You are muted, Richard.
Yeah, I was really just guesstimating. I'm thinking, well, you wouldn't put you wouldn't have all the nodes be core, just have maybe enough so that there's redundancy and so that it has reach, if it has to reach other parts of the cluster. And I thought most of the scalability goes in the task nodes. That was my original thinking.
Was an excellent thinking, but let's compare your original thinking on the previous use case to this one. What would be different here in your initial thinking? Guesstimate again.
I think, well, basically, this is going to be used by a whole bunch of people online, and maybe all of we're not going to probably scale it because it's only running between 9 and 5, so we're not going to just jump up the size of it while we're running. So I would say probably more nodes in general, and maybe I don't really know why you would have to have more task nodes, but you certainly are more main nodes, but you certainly you wouldn't be doing auto scaling.
Okay, so let's try that. So how many cores would you put in the core node count?
Well, let's start with 4 again, and then
Why 4?
Okay. Wait a minute. When you do the auto scaling, does that add task nodes, or does that, are they?
Yes, you can
does.
auto scale
Okay.
on the task nodes, or you can auto scale core nodes.
Oh, I see. Well, let's just put in 12 core nodes and leave the task nodes out.
Yeah, great. So what was your initial thinking? Why did you guesstimate 12?
So I don't know, just it seemed like a good number. Auto scaling, though, would mainly wouldn't be useful. particularly,
Yes.
unless there's some particular peak usage time, like between like 8 and 4, 8 and 10 or something, like you had this gigantic like I was just thinking commodities market, and you were trying to run the commodities market, and you had this incredible amount of usage over maybe a 2 or 3 hour period, then you might use auto scaling, but that seems like an unusual kind of way to do it. So I would just say leave auto scaling out, because it's going to be the same all day. And we've already defined it as a group of 10 analysts, so that's not going to scale.
Great, but I was referring mainly to your estimation of 12 core nodes.
Okay.
I was hoping you kind of noticed the 10 analysts, so you'll do a correlation between the amount of analysts to the amount of core nodes.
Oh, that's an interesting idea. I don't know if there's really a correlation. I was just thinking, well, let's start out with a fairly high number.
Okay, but usually there should be some sort of assumption or a formula you work when you apply resources.
Okay.
Yes, you can always start with any number and take it from there. But as architects, you want to be looking at the use case and trying to ascertain what would be the possible usage. So it's possible that those 10 analysts would work in parallel. So this implies naturally at least 10 machines.
Okay, well, if each one of them has to have each analyst has a dedicated machine while they're running, yeah, or if that's a consideration, definitely, then
Yeah,
then
great.
12 is a great number for that.
Good. Would you be using task nodes in this use case?
Probably not.
Great.
Maybe if there was some small job that had to be run in the middle of the day, or some particular job, you might allocate some space and then do auto scaling for that little section, but that's unusual.
Specific job if needed. That's a really good comment. Great. So would you be using S3?
I'd use
HDFS?
HDFS probably, because
And why is that?
HDFS is going to be faster. S3 is S3 loads and unloads in a particular order, and so it can't always get to records in the same speed as a faster storage system. And if you're running online, you want to have that fast storage available.
Yeah, great. So what would you choose going forward? The instance type, the core node instance type.
Okay, so let's see. I was thinking, well, it probably depends again on how much. How much usage people are going to put into this, and if this is like their main task. I mean, let's forget about the market idea, but let's say that their main task is they do have to have results as fast as possible.
For
So
now,
I would go
that's a good assumption.
So let's go with a fairly large CPU.
Okay, so let's take this one has 36
C4.
GPU.
Yeah, that's a good one. Yeah, that looks great.
Interesting. Great. Oops. Okay, and task node not relevant.
Nothing, right?
And for the master node?
Okay, I'm sorry, what are the choices at this point?
The master node is usually the node where all the analysts are working and typing the SQL queries and running their Jupyter notebooks. It's
Oh,
going to
okay.
need lots of memory though.
Yeah, I think that they're going to need, because each of them are doing this, that I would guess that, well, we've already kind of given them a fairly big CPU size. I'm not sure what is instant. Okay, so what is the, oh, I see. Wait a minute. So the master node is like, there's like one of them, right? So
Right.
yeah, it doesn't really matter what goes into that. That one is probably less important than the other ones.
If you remember this slide, there's three types of node, master, code, and HDFS. The
Oh,
master
okay.
is primarily used to run your job, to write
Right.
your SQL
Uh-huh.
queries. So essentially, this is your client. So a client needs to have lots of memory.
Okay.
If you
So
have
let's give
10
him
analysts, yeah, they will be
let's give
working
him
on this.
another large one then, just like that, like the rest of them.
Okay, so another one like this.
Yeah.
Okay,
I'm
interesting.
good. I'm gonna create enormous billing for AWS.
And right now, we don't care. We are having fun. We'll worry about the costs later. Would you be applying Ganglia for monitoring?
Oh, absolutely. You definitely want to have
Oh,
some kind of
yes.
monitoring,
Yeah.
because
What
this
about,
is now more critical. I mean, it's like if you're, most people experience this, like you're running along on your computer, your local computer, and suddenly the browser just completely freezes up, and it just
yeah,
happens. It's like, and it doesn't really matter whose browser it is or whose computer, it just happens. You really need that monitoring to tell what's going on.
Ray? So what about encryption?
Let's see. Well, you could have this situation where you had one of those. I don't know if all those people are in a group. They probably they can use their regular AWS encryption. If one of them was from outside, then they might want to use some special encryption.
Mhm. So S3 managed, that is, would suffice?
Okay, so if your nodes are HDFS, does it make sense to say S3 managed, or does that is
Good
that
point. Ooh, very good point.
So, Omid, I had actually a related question, right? Even if analysts are going to use HDFS, like at the end of their job, they want to save something, right? They should be still saving in S3, isn't it?
right?
Could you
That's
repeat the
true.
question, Paresh?
Like we chose S3 for the storage, right? But sorry,
For this one,
HDFS for the storage. Sorry. But let us say I'm an analyst, I run some job, and at the end of that job, I have some results that I want to share with my team or some manager or somebody, right? I need to save it on S3, isn't it?
no, why? If
Because
everybody's working on your cluster, then they have access to S3, the HDFS.
right, but after 5 like I want to email that report, to
Oh, if you want to share it outside of your group,
Right.
yes, you
Yeah.
want to put that in S3. So
Right.
what is the
Okay.
question?
So does
I
that
see.
affect the encryption then? If it makes sense, does it make sense to tell Spark that we're using S3 encryption because we're going to use S3 to save data?
Yes. If you export it, then yes.
Okay.
Why not? Does
So
this answer
that
your question, Paresh?
I
Yes,
think
it
that's,
does. Thank you.
thanks for the question.
Okay, you were saying, Richard, you had another comment?
No, I'm done.
Great. So let's talk about the billing type. What would you use? You remember the options? On demand, spot, and reserved.
Sure. Let's see.
Let's
So
consider the use case. You have a cluster that is mostly running from 9 to 5 for a group of analysts. Can we safely assume these analysts are going to be working for quite some time? Reasonable assumption, right? So should we consider anything other than on demand? For example, Spot. Should we use Spot instances for this use case?
I think definitely not Spot, right? I believe
Yes.
definitely not Spot.
Right, you are, because we don't want to lose a node during work hours. So how about reserve? Should we consider reserved?
that would
Probably
make
yes.
sense if we know that this same number of people are coming in every day. So that makes
Yes,
sense.
that's a really makes sense. John, you were saying something?
So yeah, I think so. Yeah, because we can get a discounted price, right, for reserves.
Yes, yes, really good, really good. Consider reserved. Reserved. Don't consider. Consider reserved. Reserved. Have I misspelled it somehow? Reserved.
It's just got an extra R at the end.
Oh, right,
Oh,
you're on.
it
Thank
should be
you. Thank you for that. Great. So how about the cluster configuration? Should we use any other number, any other configuration for the CPU and the RAM? One second, a question for is Ganglia about Prometheus. Prometheus is a bit over engineering. Unless it comes as part of the EMR, you don't want to be installing your own monitoring solutions. Okay, so what about the replication factor? Should we be doing something about this in this use case? Remember the use case. 9 to 5, 24/7, 10 analysts. So what would be important for the analysts? Speed, naturally, right? So would a higher application factor benefit us somehow? Well, what happens if we choose replication factor 5? June, you want to give it a go?
Not really.
Not really? Okay, so let's think about it together. Okay, if we have this slide over here about the replication factor, what happens? Remember when we started reading in terms of concurrency, a job started running, started reading the green files, which are replications of the same files, and then a node failed. So the job failed. So since we are using HDFS, what would we benefit if we have more copies of the of our files? I'll make it simple for you. It will
Yeah,
be
of course.
faster. It will be faster. So essentially, yes, Consider application factor of 3 or 5 to make things faster for the analysts. Okay? It's a bit overkill, but just to get you thinking. What about jobs? Do we need to consider any jobs? Not really, because we don't have any jobs. It's analysts doing their jobs. There's no automation in this use case. What about the storage, or the partition, or the compression, or the storage format? What should we recommend the analysts to do, to use? What storage format, for example? Do you remember the options we had? We had Parquet, we had ORC, we had Avro, we had CSVs, we had JSON files. So let's go over that a little bit.
Well, if everybody's using Jupyter, then wouldn't you use JSON?
Well, that would be a logical choice because you want to have some sort of flexibility in terms of structure. However, when you do analysis work, you want everything to run faster. Yeah, so as a rule of thumb, I would use one of these, maybe these two, either Avro or Parquet, because they are good for semi-structured and they will accelerate your performance. Okay. What about compression? Should we apply compression? There's really nothing to lose. Always apply compression. You only save money here. Okay? What about encryption? Always, right? Okay, guys, let's conclude for today, unless you have any more questions about this use case. So let's summarize. What did we learn today? Please open your mics and let's talk. What did we do today?
How to size and design a cluster depending on the workload.
Yes, great. We had some sort of a framework to think every step of the way from the use case, right? So what would make your EMR faster based on what we discussed today?
Instant type.
Instance type, right? What else?
Memory, CPU, storage.
Right. Storage, what else? Configuration. Remember the slide? It greatly affects on what you're trying to achieve. You need to bear that in mind. Okay, what would make your EMR cheaper?
Spot instances.
Sorry?
Spot instances.
Spark instances, yes, but more specifically, if you remember, billing type, right? Great. What about simplicity? What would make your EMR simpler? Should we use S3 or HDFS? What would be simpler?
S3, right? With no limitations.
S3. Yes, exactly. So, guys, essentially, data engineering is all about faster, cheaper, simpler. You can do some homework should you wish. Log into your master node and look for yarn, HDFS, and Spark configuration files. Just review them. Do not try to change them. Review EMR Spark configuration documentation and run any Spark example job and review Ganglion monitoring. That should give you a really good sense of what we discussed here today. Call to action. We have our website, Big Data Demystified. We have global reach groups all over the world, so you're more than welcome to attend our meetups. Subscribe to our YouTube channel. It will help us greatly to spread the rumor about this wonderful session. Should you wish to stay in touch, you're more than welcome. This is my private info on LinkedIn, my cell phone, all the necessary links. And unless you have any more questions, we can
Yes,
wrap it up for today.
Yeah, I have one question. So, were you saying that S3 is more simpler? So
Yes.
okay. So what does that mean that because S3 is managed by AWS or something else? So why would we would say it's simpler?
It's simpler because you don't have to maintain it. It's a storage layer, if you remember from previous sessions. Allow me. We
so you mean
discussed.
Okay, replication factors, right?
We discussed the fact that S3 is scalable. Where's the advantages? That it's a managed service, that it's multi-petabyte supported, that it's highly secure, has a scalable throughput, that it's truly decoupled, that it's cloud native architecture and you have a high availability and disaster recovery in a click. It's fault tolerant, fine grained security, and it's easy data governance. So it's really making everything very, very simple. When you want to go big, you want to go secure, you want to go. Yes.
Okay.
So this is what I meant.
But compared to HDFS, right? So HDFS we want to manage ourselves, right? Like in this case, because EMR.
Here's your answer. When you manage it yourself, it's more work, so it's more complicated. When you don't have to manage it, it's simpler. It's not like I'm saying use S3 for every use case. We saw today.
I'm just okay. I understand. I just want to compare to HDFS. It's even simpler, right? So.
Yes, it's simpler.
But it depends on if you're trying to decrease the time of getting data into EMR, then HDFS is going to be easier to deal with. You're going to spend a lot of time trying to figure out how to do things in S3 that you probably
can't. Yeah, I got the same issue. You're very complicated. So that's
Yes, exactly. The round trip time issue from EMR to S3, naturally. And if you're using a private network or using the web, yes, there are lots of consideration to do to minimize time. Okay, guys, any other questions?
Thank you very much.
You're most welcome, Richard.
Yeah, thank you.
Okay, guys, thank you very much. It was my pleasure to host you here. I hope to see you again in future sessions. Feel free to check out our website and our meetup groups for future events. And let's keep in touch.
Thank you.
Hi, Amit. I have a question.
Please.
Yeah. I just actually wanted to know your views about Hadoop 3 and also on the EMR 6 version, which is having Hadoop 3. How stable is it? And how Hadoop 3 will will make a difference as compared to Hadoop 2 and the cloud environment as well.
You're talking about the different distribution, Hadoop open source versus EMR distribution?
No, I'm just talking about the Hadoop 3 thing. How will it make a difference as compared to what the Hadoop 2 we are using, even if it's an enterprise EMR or Cloudera or any other?
I'm not sure I follow. What are you trying to compare EMR and what?
So EMR, it's actually everything is all about Apache Hadoop, right? So how Apache Hadoop
Yes.
3 is making a difference is my question. How will it make a difference? This is my first
Make a
question,
difference.
and the second question is how will EMR 6 is having Hadoop 3 version, Apache Hadoop 3, like the backend is Hadoop 3. So is it stable or not? Is my
Are you talking about
question.
Hadoop version 3?
Yes.
Oh, now it's good. Yes, it's making a difference. Definitely. You have Spark 3, which has lots of benefits. One of them I didn't go over today, but it's the adaptive engine query. If you noticed in the, allow me to share screen again. Yeah, if you notice in the job configuration, cluster configuration, there's an AEQ, alternative execution query, which is essentially allowing you to recompile the execution engine during runtime, not only once in the beginning. So it essentially making every job faster. So yes, there are great benefits of using Hadoop version 3.
Okay. Thank you.
You're most welcome. Any other questions? Okay, guys, pleasure meeting you. Hope to see you all again. Thank you for your time.
Have a great
Bye.
day.
Thank you. Bye-bye.
Thank you, Umar. Thank you so
Let's-
much.
Bye.